Welcome to this Mechanics of Solid Unit 2. So, where I'm going to talk about shear forces and bending moments in the mechanics of solids. As I've discussed previous Unit 1, now I'm going to Unit 2 to discuss more about shear force and bending moment questions in a simple way, in a better way, so that a student can understand. Here, try to understand my explanation and get better into your knowledge of the mechanical engineering mechanics of solids. So here I will go. So what is the question here is if your first question is here define, you can take define shear force. What is the shear force and bending moment? So what is a shear force and bending moment? So shear force is nothing but the algebraic sum of vertical forces at any section of the beam. So all the vertical forces, for example, here all these vertical forces, you can say all these vertical forces. If I am taking this beam, if beam is having this force F1 and force F2. So this F1 and F2 algebraic sum. So you have to take the algebraic sum of this all forces to the right of the beam or left section of the beam. So you can divide this beam here and you can make this is a right side of your beam and the left side of here. You have to equal them. So then this is called as algebraic sum. So what is the bending moment? So bending moment is as per the definition given the algebraic sum of moments of all the forces acting to the right or left of the section is known as bending moments. So all the moments, but this is a beam. If this beam is attached by moments M here, one twisting force, and here some bending force is there, M1 and M2 if you are taking. So these are the moments here make. So a beam is there. If it is a beam, so you have to clockwise one force is acting, and here also one force is acting. So you have to count all these bending moments. This bending moment is taken as the M1 and also it is taken as M2. So these movements are called as bending movements, and these forces, vertical forces from up and down, all balanced shear force. So this is the very important of this unit, ma'am. Here, if I am not wrong, I am taking the next question, ma'am. What is the next question is what is the beam here? So what is the beam? Define beam means if you are going to second question, see beam is what are the beams? What are the different types of beams are there? So beam definition, if I am taking a structural member, any structural member which is taking load, which is rigid, which is capable of resistance. So it is acted upon by system of external loads. So any external loads can be acting on that at right angles to the axis is known as beam. So definitely there should be a beam. What is happening is if example this is a beam. If I am taking beam, so this is a structural member acted upon by some external forces or external forces are right angles only. So right angles means this is a right angle 90 degrees angles. You can say this is the at the axis only. So this is the beam is having some axis here. Center of this is the axis. So this is the beam. This is also a structural member. Now what is the types of the beams also explained here. You can see this is a beam here, one side supported. If it is beam is one side supported or one side fixed, it is called as cantilever beam. Here one more beam is there which is supported by two vertical forces from the downward. So this is called as simply supported beam. This is a fixed beam. As per the definition, a beam which is fixed at one end and free at the other end is known as cantilever beam. So this is the cantilever beam. Here it is free. Here it is a fixed end. So this is the beam of a this one cantilever. According to the simple supported beam, define what is the simply supported beam. A beam supported freely on the supports at its both ends. So this is one end, and the other end is this one. So both are supported from the downward direction. Then it is called as simply supported beam, as set for the definition and diagram. So the third question is overhanging beam. What is overhanging beam? If the end portion of the beam is extended beyond the support, we can see this is one support ma and this is one support here. So this extra beam is coming beyond this support ma. So this is called as overhanging beam. This can go up to here also. So here the support is there. Beyond support we are going. Here we are not going beyond support. Here also we are not going beyond support. But in this case we are going beyond support. That is what it is said to be the this one ma special case here. So types of beam, so fixed beam ma. So you can say this is a beam. This beam is fixed here and fixed here. Two sides it is fixed upon. So if it is two fixed here and here, then it is called fixed beam. So any loading should be done and to be done at the center only. Okay, a beam whose both ends are fixed are built in walls, or you can build walls here. Two walls are built here, so it will not move anywhere, but there is chance of moving in these directions. What is continuous beam? A beam which is provided more than two supports. See, more than two supports. Here one support, two support, three support, four, five supports are there. If anything, a beam which is having more than two supports, it is continuous beam. It will go like that only. It will go like that only. So this is the difference between this continuous beams and continuous beams here. So I think hope you have understand this one. What is beam and what types of beams? So types of beams cantilever, simply supported, overhanging, fixed, continuous. But this cantilever and simply support very important. As per our syllabus, we are more discussing about that. So so I will clean this one so that you will not get this one. So, so next question I am going to take that is the third question. I am going to take here. Third question is what are the different types of loads? So very important, very easy to understand. That is what are the different types of loads. So the different types of loadings are point load Here you can see point load is there. So it is a simply supported beam as we discussed in the previous question. One weight, one vertical force is acting at the center point, which is called as concentrated load or point load here. A load, point load is the one which is considered at a act at a point. So only one point, only one load in the beam is called as point load. So uniformly distributed load. Here we can see this is a simply supported beam. Continuously some chain type of some water or some soil or some liquid is there. This liquid is span over this one. How much of length is there uniformly? It is distributing the uniform load. Then you can take the weight of the water here in Newton per meters. Then as per the definition, a UDL is one which is spread over a beam in such a manner that rate of loading W is uniform along the length. So W is there all spread upon this length mass. So it is a UDL load we can call it. So what is the UV load? So UVL load is you can see here uniformly varying load mass. So uniformly varying load is like, see here. So at this point, the load is very small. Load increase, load increase, load increase. Continuously, load is increased, and maximum load you can see here only. So till that you can't see. So it is not constant loading. It is this is the load 1, 2, 3, 4 like that. Is what is happening? It is increasing load. So this is also a simply supported beam. We can say SSB beam only. So this is a simply supported beam here and here. So all the cases 1, 2, 3, 4, you can see they are all simply supported only. But the loads are varying here. The UVL load is one spread over the beam in such a manner that rate of loading varies from point to point along the beam. Definitely, this point load is varying this point varying this point is varying this point. So in which load is zero at one end and increases continuously. So one end it is zero and the maximum load is here. So zero to maximum load you can see at the end of this. It can happen from this direction or this direction. Anything it can be happen and increases uniformly to the other end. So this is the explanation of different types of loads. What I am saying, point load, UDL load, and uniform load. So diagrams also here. So I'm not drawing the diagrams now. You can see three diagrams are shown for your clarity purpose. So if I'm not wrong, I'm going to the next question. Define sagging and hogging. So what is the defined is sagging and hogging means? You can see this this you can see this one here, sagging and hogging. So what is this sagging and hogging is? So this type of loading. So concavity is called. If the loading is there, it will go inside. It is called as sagging. A smile is there. A smile on the face like this. It is called as sagging. So yeah, this one. This is opposite. This is a hogging. So a bent is a when load is happening, a beam is bent downwards. A beam is when the loading here, a beam is bent upwards. So this is the two types of sagging and hogging direction. If I'm not wrong, I'm going to take the definition for this sagging. Sagging is a purely it is a positive bending movement. The bending movement at a section as positive only. If it is tends to bend a beam to a curvature having convectivity at the top as shown in the figure, the positive bending moment is often called a sagging moment. This is called a sagging moment. So sag is like S type only. It is also and it is a positive. So what is hogging, ma? What is hogging is it is a negative bending movement. It is very important to understand as per our syllabus. So bits are 2 marks questions it will come. The bending moment at a section as negative only. So if bending a boom is done like this, ma, it is negative. If it tends to tend the bend curvature having congruity at the top of the figure, a negative bending moment is called a hogging moment. This is called as hogging moment. So for the idea, we need to have all these small definitions into your mind so that you can understand the big questions of this unit, mark. So if I'm not wrong, I'm going to take this next question, ma. Here you can see what is the point of contraflexure. Point of contraflexure. This is a point where bending moment is zero. After changing its sign from positive to negative and vice versa. So a point of change will takes place. For example, a beam is there. If you are taking a beam here, if you are taking a beam here, if one more force is here and one more force is acting from downwards upwards, definitely this beam will bend here, because this is a force vertically acting downwards, and definitely this part will go down, and definitely this part will go up, here you are having a point of contraflexurity where sign changes. The bending moment is zero after changing its sign from positive to negative or vice versa. This can be taken from positive to negative or negative to positive, So this depends on these values of this bending, So this is called as contra fracture. So sixth question, if I'm not, I'm taking, So what is the sixth question is I'm taking here. So derive the relation between the shear forces. So derive the shear forces. So what is a shear forces? A definition I am given before only. So anything which is related to the uh, forces vertically acting upwards on a beam is called shear force. Some of the algebraic, some of the forces you can say. So bending moment is some of the this all the some of the all the movements in a beam is called as. So here directly, this is in this figure you can see at the x distance. This is simply supported beam which is having a UDL loading, This one and two section. We are taking at a length of x distance from the starting point, x distance. If I am going on the beam, there I am taking a section. So here you can see this F is there. If F is acting upwards, definitely F plus DF force is developed in the downward direction as you are seeing here. So F is there means F plus DF is there. M is there means M plus DF automatically generated forces. So if you are going to do minus here, you can get a formula called as df by dx is equal to minus W. So F is what here means shear force. So Df is the change in the force with respect to x-axis is equal to minus work done. So at the same time, if you are taking this m and m plus dm, so the change in the moment of the forces with respect to x is equal to f. What is the f here is a force which is given by this bending moment. So bending moment is given by force. If some force is there, moment is developed. If force is there, some work is done here. So difference in the force with respect to x is given by minus w. Difference in the movement with respect to x is given by AF, which is the derivation of this shear force and bending moment here. Okay. So I hope you have understand this explanation. This is very important for 2 marks question in this unit. Hope you understand. So I am taking the next question. That is the seventh question. This one. What is happening here? The seventh question is draw the shear force diagram. So this is the simply supported beam. A point load is acting here. If point load is acting, this is a positive direction. They definitely here the positive to negative the sign has changed. If this is W, here W by 2, here W by 2, because this W is acting by this half length. So W by 2, W by 2. So SFD means the shear force diagram for this diagram is given by here this rectangle. So rectangle portion is coming. This is a definitely two triangles are coming for this SSB beam at a point load. So this is the SFD. This is the bending moment. Here, WL by 4 is given. WL by 4, which is a positive direction developed for this bending moment. So this is for you have to remember for 2 marks or competitive exams. So if I'm not wrong, I'm taking the next question, ma'am. That is eighth question. Define, draw the bending moment diagram for cantilever beam. So this is a cantilever beam here. One side supported, on the other side it is free. So what is happening here? It is W is acting here. W acting for meter length here. So it is having a length of L direction. So what is happening is so it is acting, W is acting totally on this length So it is given by W into L, W into L, which is the shear force diagram, shear force diagram. So this shear force diagram is also given by this inclined line It is inclined line. So that this is a positive inclination. This is a negative inclination. This is the bending moment diagram, which is given by WL into L by 2, WL into L by 2, which is WL square by 2 for a bending moment diagram. WL is given by shear force diagram on this length M. And next, draw the shear force diagram and bending moment diagram for the cantilever shown in the figure below. So, shown in the figure below. Draw the shear force diagram, bending moment diagram. So this is the you can take here. This is a cantilever beam. One side supported, other side 1 Newton is acting for 1 meter of length. So here it is given by a rectangle The shear force is given by all the these directions are taken only here. It is 1 Newton is acting here. 1 Newton is acting. This is a shear force diagram. Then this rectangle is given by inclined negative inclined, negative inclined triangle is formed here. Negative triangle is formed here. This is the bending moment diagram for this. Any cantilever beam. So you can say what is the shear force acting at the B is 1 Newton. What is the shear force acting at A is 1 Newton. What is the bending moment B is given by here starting 0 it will be. What is the bending moment here acting means 1 into 1 Newton meter because this length is 1 meter, so 1 Newton. Here it will be 1 Newton meter. So this is the end of this questions. 9 beautiful questions and basic questions I have covered in this unit 2. So all this sagging and all the fixed beam, simple beam I have covered in this unit 2 of shear force and bending moment. Hope you have understand all the things and it will be helpful for your studies. If anything The suggestions is there. Please, you can write down and you can get your knowledge in this mechanics of solids and mechanical engineering. Hope you have understand and thank you for listening this video. Ma. Any suggestions? Please write down here. I will be putting into my next video. Thank you. Thank you very much.